Hello class, so this is the first in a series of videos to help you work on your summer homework. This is geometry review, so you should have noticed in there's a fair amount on geometry, specifically on triangles and angles. So for this geometry review, we're going to be going over Pythagoras, like Pythagorean theorem, Sohcahto, which hopefully you know is an abbreviation for sine, cosine, and tangent rules, 3 inverse trig functions, and 4 how parallel lines are useful to you. So if you can notice from this specifically, we're going to be focusing on right triangles on this one. If you want, you can take notes. There will be some practice examples that would be good for you to try if you are unsure. Alright, so first is Pythagoras. Hopefully you know that this only applies to right triangles. You cannot use Pythagorean theorem, Sohcahto, that sort of thing on anything but a right triangle. So by right triangle, hopefully it's been drilled into you, a right triangle is when one of the angles is at 90 degrees. What this creates for your triangle is you get 3 different sides. Specifically, you have one straight side, another straight side, and C. Hopefully, this longest side you know has a fancy name. That name is the hypotenuse. If I spell that wrong, my spelling's bad, my math is better. This is the hypotenuse. The best way you can tell the hypotenuse, one, it is the longest side on your triangle, or on your right triangle, to be specific. It's also the side directly opposite from your right angle. So the formula that we use or what is Pythagorean theorem, is A, one side squared, plus B, your other side squared, is equal to your hypotenuse squared. Your A and your B do not matter. Your C does. Your C must be the hypotenuse. Alright, so for example, if you are solving these, say we have some right triangle, we have our hypotenuse. Hopefully you can tell that this is your hypotenuse because it is on, that was a terribly drawn C, because it is opposite of your right angle. Which one you want to call A or B, it really doesn't matter. I tend to make A the one at the bottom, but again, it doesn't matter which one you used. So then you want to set up your equation where you have your x squared plus your b squared, or your 4, is equal to 5 squared. From here, it's just algebra. Hopefully you know that 5 squared is 25, that 4 squared is 16, and we don't know what x is. Subtract 16 from both sides. Remember, if you do it to one, the opposite of addition is subtraction. If you do it to one side, you must do it to the other side of your equal sign. Then you should, if you put this in, it's 9x squared. Hopefully you know what the square root of 9 is. You'll get x equals 3. Alright, so Sohcahto is the second thing we want to talk about. It is the same with Pythagorean theorem in that you must have a right triangle. If you do not have a 90 degree in your triangle, it will not work. So labeling is very important for this, in the sense that you have to know that your hypotenuse, that really doesn't look spelled right. Anyway, your hypotenuse is across. Your other 2 labels are highly dependent on an angle you're given. Often in these, they'll give you some angle. We often write this as theta. This is the Greek letter theta. And your opposite and your adjacent are labeled based off of your theta. So for example, when I say opposite, I mean it's opposite of your theta. So this would be your opposite side. If it's adjacent, it would be adjacent to your theta, hence called the adjacent side. So this side here would be your adjacent. So it all depends on the location of your theta. The hypotenuse is easy to find because it's directly opposite, but your adjacent and your opposite sides are highly dependent on where your theta is found. So hopefully you know that Sohcahto stands for things, where So is a short for the sine of theta is equal to the opposite over the hypotenuse. The Ca is short for cosine of theta is equal to the A adjacent over H, the hypotenuse. And Toa is short for tan of theta is equal to the opposite O over the adjacent. So, make sure when you're doing these equations or anything with Sohcahto, make sure that when you are doing it, say if you wanted to put tan 37 into your calculator must be in degrees mode. If it's not in degrees mode, if it's in radians, you will absolutely get the wrong answer. So make sure that you check if you're in, especially if you're in pre-calculus. This can be very frustrating because you'll probably have to be in radians for that class, or at least part of that class. So be very good at switching back and forth. If you were to say plug this into your calculator, you should get 0.75. If you did and you did not get 0.75, you are not in degree mode. Alright, so this is just an example. So when you're using examples, you should pause the video and then try it by yourself and then come back for the answer. So right now, pause the video, try to solve for x without my help, and then come back. Alright, so first thing you need to figure out is what is your hypotenuse and what is not. So hopefully you can look at this and know, hey, this is a cross, therefore this is my hypotenuse. Also, this is your theta right here. So therefore, if your theta is right next to it, that makes this one your adjacent. So we have a hypotenuse and an adjacent. So if you remember from Sohcahto, the ones that has an A and an H in it is Ca. So you're going to be using cosine of theta is equal to your adjacent over your hypotenuse. Now you want to set it up. So the cosine of your theta, which is 32, is equal to your adjacent, which is 1.5, over your hypotenuse, x, we don't know it yet. You want to do some algebra so that these will multiply to 1. Get it to the other side. And then we want to get x alone. So we would also divide by cosine 32. Remember, division is the opposite of multiplication, so since they are being multiplied, we would divide here. These would also cancel out, so you have 1, or x equals 1.5 divided by cosine of 32, which equals 1.77. Okay, so here's your example 2. Again, please pause, try it on your own, solve it. Now that you've tried it on your own, remember first you gotta identify which is which for everything. So hopefully you know, hey, that's a cross, therefore that's the hypotenuse. Then you want to look at where your theta is. Your theta is not on the same side as your x, so therefore that makes it the opposite side. So we have opposite of and hypotenuse, which should cue you to think, okay, well that sine of theta is equal to the opposite over the hypotenuse. If you don't have Sohcahto memorized, now would be a good time to start memorizing it. So from here, again, you want to plug in, so sine 63 is equal to our opposite x over our hypotenuse, which is 20. You want to move 20 over to both sides. So you get 20 times sine 63 equals x. Plug that into your calculator. And you get 17.8. Sorry, I realized I forgot to pause the video while I was plugging it in and had to find my calculator. Moving on. Alright, so next is inverse trig functions. Again, this is right triangles only. So when you be using inverse trig functions is where you have enough numbers, but you do not know your theta. So what you have are tan inverse, sine inverse, cosine inverse. These are the same thing. Depending on the age of your calculator, who made it, they might write them one of these ways. And the whole point of these is that these undo your sine, cosine, and tangent. So just as subtraction undoes addition, or division undoes multiplication, these undo your sine, cosine, tangent. So an example. So looking at this, you can see that this is your hypotenuse, and this is your adjacent, because it is right next to the angle. So again, hypotenuse and adjacent will get you cosine, so you're still going to want to say, okay, cosine of my theta is equal to my adjacent over your hypotenuse. Same rules apply as Sohcahto, except this cosine is definitely getting in our way. So we have to undo it. And the way that you're going to undo it is you're going to take your cosine inverse, or your inverse cosine, around your cosine theta. And if we do it to one side, you have to do it to the other. This is going to cancel out your cosines, leaving just theta is equal to cosine inverse of 3 over 5. And you can just plug this into your calculator. And if I put that in my calculator, I end up with about 53 degrees. So parallel lines are very useful to you and will continue to be throughout your time in AP Physics. So parallel lines are lines that never touch. And most importantly, we have to think about what happens if we have it in a line that goes across our two parallel lines. We have a couple things that show up. So main thing to know is that opposite interior angles are equal. So you can see these in pink here are equal because they are on opposite sides of each other, and those in green are equal to each other. This will help you figure out angles that you may not necessarily know because you know their partner angle. Also, looking at a straight line, you know that all angles on a straight line must add up to 180. Alright, hopefully this is helpful, and I'll see you on the next video.